Question 1. Okay, this question is about the adsorption of ethane dioic acid on this activated carbon. And okay, before beginning the experiment, 500 cm cube of 0.139 mole per dm cube of the ethane dioic acid solution X is made, and the activated carbon is placed in the oven for 120 degrees C for 3 hours. Most likely is to remove water. Now, the experiment procedure is quite simple, only 5 steps. Prepare 100 cm cube of 0.0556 mole per dm cube of the acid solution, which is X. Step 2. Transfer 50 cm cube of 0.00556 mole per dm cube into the conical flask. Something like this. After prepare, transfer 50 cm cube to the conical flask. After that, add 0.5 grams of the activated carbon and start the stopwatch, start the timing, and shake the flask and immediately remove 5 cm cube sample from the flask. Determines the mass of the non-adsorbed acid in the sample using the chromatography. So from this procedure, we should know that the mass of the ethane dioic acid, it will getting lesser from time to time because it's being adsorbed by the activated carbon. So means the activated carbon will take the acid from time to time, okay, because the adsorptions happen. Okay, the last step, repeat the step 4 at a suitable time interval until there is no further change in the mass of non-adsorbed this acid in the sample, which means the activated carbon already saturated. So means the mass of the non-adsorbed acid is no further change, means constant. Means the activated carbon cannot really take the acid or the solute anymore. Okay, so that's the steps and the main idea of the question, so of the experiment. Now, part A, solid ethane dioic acid has the formula of this COOH, okay, bracket 2, so it's a dihydrate, 2H2O there. Okay, now calculates the mass of this acid required to prepare 500 cm cube of 0.139 mole per dm cube of the solution X. Okay, this one is quite simple. Of course, you need to get the molar mass of the this ethane dioic acid first, which is 126 gram per mole, and after that, you need to calculate the mole of the acid solution. So 500 cm cube, 0.139 mole per dm cube over 1000. So you should get 0.0695 mole. Okay, this is the most of the acid needed. Then the mass of the acid, therefore, is the mole times the molar mass. So you will get 8.757. Okay, so this is the mass that needed. Now part 2. The mass of the ethane dioic acid dihydrate calculated in part 1 is placed in the pickle. Describe the steps taken to prepare 500 cm cube of 0.139 mole per dm cube of the acid solution. Give the name and the capacity of the apparatus used. Okay, first we need to add water, distilled water. Don't just put water, distilled water. It must be the small amount. Okay, let's say we add 50 cm cube of distilled water in the pickle, because the pickle already it has the solid acid in there. So we need to put the small amount of water to dissolve the 8.757 grams of the acid. Okay, once it's dissolved, then we need to pour the solution in the pickle to 500 cm cube volumetric flask, because it's need to prepare 500 cm cube. So the VF that we use must be 500 cm cube. And once the solutions pour into the VF, because there is some residue on the pickle, so we need to rinse the pickle with distilled water. After that, add the washing to the VF. Make sure all the particles or all these acids get into the VF. After that, add distilled water to top up to the mark, to top up to the calibration mark. Put a stopper, invert and shake the flask to homogenize the solution. Okay, that's a full procedure. Okay, part B. Ethene dioic acid dihydrate is corrosive. Other than wearing eye protection, means goggle and a lab coat, state one safety precaution that should be taken when use this solid. It's corrosive means we can use another protection, which is chemically resistant gloves. Again, try not to just mention gloves. Must be chemically resistant gloves. Okay, C. Suggest why activated carbon is placed in the oven before use. So I told you just now in the procedure, most likely is to remove water from this carbon surface. Right. Part D. In step 1, solution X is diluted to a concentration of 0.00556. So which means is from 0.139 dilute to this concentration. Okay, now calculate the volume of solution X needed, the more concentrated one, which is a 0.139, to make 100 cm cube of 0.00556 mole per dm cube of the acid solution. Okay, so because this is a dilution, you just use N1V1 equal to M2V2. Okay, let's make it the N1V1 is the more concentrated one, M2V2 is the one that being diluted. Okay, so you just put the concentration here, 0.00556 times 100, and here is 0.139, the more concentrated one. Okay, then the V1 means the volumes from the more concentrated solution. Okay, now is 4 cm cube. Okay, part E. Identify the most appropriate piece of equipment to transfer 50 cm cube of dilute acid solution in the step 2. You can use either one. Can use a burette, or you can use this volumetric pipette. 50 cm cube burette also can. 50 cm cube volumetric pipette also can. Suggest a reason why conical flask is shaken in step 4. Oh, this is very easy. Whenever we shake, means we want to make sure the sample mix evenly, right? Uniformly mix the sample. Okay, part G. The results of the experiment are shown in table 1.1. Now this is all the time from 0 to 150. After that, this part is the mass of non-adsorbed acid in the 5 cm cube sample. Okay, so it started from 2.5. This is the total mass in milligram. And after that, this one is the mass of the acids adsorbed by the activated carbon. Okay, when the T equal to 0 means when just started, of course the adsorption is not really there. So here is 2.5, here is still 0. When the time is getting longer, 5 minutes, so now this one is getting lesser and this one is getting more. The mass of the acid adsorbed by the carbon. So because the total mass is always 2.5, so you use 2.5 minus 1.9 here, you get 0.6. Do the same calculation, 2.5 minus this one, then you get this one. Right, so do it for all, you get this. Means when the time is getting longer, the solute, means the acid that adsorbed by the carbon is of course getting more until it gets saturated, which means from time 120 minutes here already being saturated. okay, because it's the same value here. Okay, so now done already. This one, table 1.1, complete that. Okay, part 2, plot a graph in the figure 1.1. Show the relationship between the mass of the acid absorbed by the current in the 5 cm3 sample and time. Draw the curved line of best fit. Oh, so this is a curve. Okay, let's check. You should get the graph something like this, best fit curve. Okay, when you plot, one important part is do not forget this one, because in the table just now there is one plots here, here 0.00. So when it started, t equal to 0, so it's 0.00. Make sure you plot here as well, right? Then you just follow the table. Okay, plot all the all the time, so each of this time, and then you draw the best fit curve, and this is the anomalous point, right? So means when this time getting longer, then obviously it's getting saturated, as I told you just now. Okay, next part, identify the independent variable. So this one is quite flexible. As you can see here, different time, then the mass of the solute that being absorbed is different. So means we can actually change the time. When time different, then the mass of the solute absorbed is different. So the independence variable is the time of the sample removal. We can actually control the time. We can choose which when is it. Okay, suggest one variable that needs to be controlled that is not stated in the experiment procedure. It must be a temperature. Temperature must be constant. Then the absorption, it can be done in the same condition, right? Now, okay, for part 5, circle one point on the graph that you consider most abnormalous. So it's quite obvious just now. Okay, explain the error in the timing that may have lead to this anomalous point. Okay, let's check this one. Okay, this anomalous point is quite easy to explain. Okay, because now at the time equal to 30 minutes here, right? So this is the anomalous point. It's supposed to be somewhere here. Means the mass of the acid that absorbed it should be here, means it's more. Why is the mass of the acid that absorbed by the carbon is lesser than expected at the same time? Means the time that used is actually shorter than 30 minutes. When the time is shorter than 30 minutes, means the mass of the acid that absorbed by the carbon is lesser. That's the reason. So that's why we have this. The actual time of the removal is actually lesser. Lesser means the absorption, the mass is lesser. Okay, part H. So we have these MI, ME, and MI minus ME, QE, and ME over QE. A lot of results here. So we are not going to go through one by one. So what you need to know here roughly is this third column is the mass of the acid that being absorbed. Okay, so let's see what they asked first. And okay, for part 1, plots of the ME over QE against the ME give the line of best fit shown in the figure 1.2, which is this one. Okay, this one. Later we come back to this figure 1.2. Okay, this one is equations given. So obviously, because it's okay in this graph, is a ME over QE versus the ME. So obviously the gradient is this one 1 over Q, right? Because it's this one versus this one, ME over QE versus this ME. So 1 over Q 0, right? So it's the gradient. Okay, so use the gradients determines in H1. This one we still not yet really discussed. Okay, so for part 1, quite easy. Just use the figure 1.2. Get two coordinates. Make sure the coordinates they are as far as possible, right? Make sure it's cover at least more than half of the range. Then you just get the difference, delta y over delta x. Okay, get the gradient. So you should get roughly 0.0108 gram per milligram. So this is the one that you can get from this figure 1.2. You can get any two coordinate, but you need to make sure they are as far as possible, right? Just get the coordinates from this. Okay, I got two coordinates. You can try and get two coordinates from these lines. Okay, so once you calculate, you should get this. Then use this gradient for the part 2. Gradients, so it's equal to 1 over q, q0. So therefore, if you want to get the q0, means or q0, so it's 1 over 0.0108 means the gradients that obtained just now, right? So 1 over the gradient, you get roughly 92.5 milligram per gram. Okay, this is how to do. There are a lot of things here. Of course, some of the information is not really going to use for the question. Okay, now for this part I. The experiment is repeated and the value of this Q0 is calculated to be this 78.1 milligram per gram. The total percentage error from the experiment procedure is about 6.5%. Okay, the data book means the theory value for the Q0 is 86 milligram per gram. Okay, so okay, let's just check what is the Q0 to make it clearer. So absorption parameter, so this Q0 is the maximum mass of the acid absorbed per gram of activated carbon. That's a Q0. Okay, so this one is quite different. This is from the experiment. Okay, the maximum mass that being absorbed, and this is from the data book, means the theory value. Okay, use this information to determine whether the error is in the repeated experiment could be accounted by experimental error or is caused by other factors. Okay, this one you have to compare, because it's given two value. One is theory, one is actual. So you have to compare the actual and the theory. So the percentage error of the experiment results compared to the data book, okay, means this one compared to this, is we just use the theoretical minus the actual over the theoretical times 100%. So you get 9.2%. Okay, compare this percent with this 6.5 experimental procedure. Okay, the percentage error from this experimental procedure. So this percentage is larger than this percentage error from the experiment procedure. So means there is an extra error there, and yes, most likely is contributed by other factors as well. Okay, so that's how you solve this question. Okay, that's all. Thank you.